What's going on, guys? Today, Thursday, October 1st. Just quick recap of yesterday's lesson and discussion. Free fall, okay, basically is when only an object is being acted upon by gravity. So after you throw something, there's no longer a force acting on it. We're neglecting all kinds of air resistance. All right, so we're treating everything as if it's in a vacuum problem. Now, in the video that you have watched in the link, they tell you that the value for gravity is negative 9.8 meters per second squared. Yes, but for this course, we're going to use negative 10 meters per second squared because it makes our calculations a little bit easier. So in the video, they also explain that the acceleration of a falling object does not depend on its mass. Again, in a vacuum, all objects are going to accelerate at the same rate, and that rate is the rate of gravity. Gravity always pulls things downward, so if you forget that, just take your pen or pencil, drop it. That just really went way far over there. And back. So, God, I wasn't sharing this. That's okay though. So gravity always accelerates things in the downward direction. If you throw something straight up in the air, all right, at the very, very top of its path, it's at rest for that instant in time, changes direction, comes back down. So at the top of any, or at the maximum height of any projectile, okay, or any object that's moving through the air, or we deem it as a free fall problem, the velocity is 0 meters per second. But gravity is still there. Gravity never shuts off, so it's negative 10 meters per second squared as the acceleration. And if something is accelerated downward at this, explain how the velocity changes every second. So if you throw it upwards against gravity, it's going to slow it down by 10 meters per second every second until it hits 0. All right, so it stops, changes direction, comes back down, and then it speeds things up at 10 meters per second every second. Now, going into these kinds of problems here, all right, the vertical motion problems that you would need if we're dealing with projectile motion to have the vertical motion parts of this. So this is the equation that I'm using here, which is Vy, which is your vertical velocity. I kind of wrote them out for you. Vi, your initial velocity, and Gt. Now, some places may use At or A sub Gt, still the same thing. Now, in our problems, we're using negative 10 meters per second squared. If an object is dropped, its Vi is 0. If it is launched completely horizontally, your Vi is 0. Pretty much if they don't tell you it's being thrown at a certain speed, up, down, at an angle, okay, anything like that, the Vi is going to be 0. So here's your equation. What would the velocity of the ball be at 6 seconds if they were thrown straight up with an initial velocity of 42 meters per second? So here are our variables. Let's break them down. We have 42 meters per second. Our time is 6 seconds. Gravity, always negative 10 meters per second. Now, again, to show the squared part of this, you're going to hit Control period. You'll see the cursor jump up. Press 2 for the square, and then Control period to get it to go back down to regular. Vi is our question mark, or Vy, I apologize, is our question mark. So we're going to use this equation. So I'm just going to jump back up over here. So V, now to get the subscript, is Control comma. So V sub Y, Control comma again to get it out of there, equals, and now let's type in our numbers. Vi, 42. We're going to add that to negative 10 times our 6 seconds. All right, so get your free calculator, type in free calculator in Google, and let's just work this out. Okay, you can do 42 plus, all right, your negative 10 times 6, and you're going to get an answer here of negative 18. Negative 18 meters per second. So let's take a look, go back to our problem. Yeah. So 10 times 6 is going to be negative 60. Add that to it. So you're going to get your answer here of this negative 18 meters per second. Okay, so please, like all of our problems that we do, highlight this in red. Highlight your answers in red. Okay. So the next problem, apple falls out of a tree, takes 1.75 seconds to hit the ground. How fast was the apple going when it hit the ground? They don't give us an initial velocity here, so it's 0. Time, 1.75 seconds. G, it's always negative 10 meters per second control period squared, control period. We're looking for Vy. So scooting over here, V, control, comma, Y, control, comma, equals, let's type it in, 0 plus negative 10 times 1.75 equals. And this is going to give us, all right, 0 plus negative 10 times 1.75. So we're going to get a negative 17.5 meters per second here. Now, the negative velocity is just indicating that it's on the way down. If you ever get a positive velocity, that is telling you it's on the way up, okay? Then you guys will be able to do this third one on your own. So we get to the next portion, vertical displacement. So dy is equal to VIY times t, I'm sorry, VI times t plus 1/2 GT squared, where d sub y is your vertical displacement. Remember, displacement is essentially distance with the direction. So if you can have a negative displacement, that's just going to tell you that the object is below, all right, where it was originally. But if they do ask you in a problem, oh, so how high up is this? You're still going to use this problem. You still get your answer, but you can at that point lose the negative sign because you can't have something that's negative, 15 meters high. Make sense? Okay, so let's roll through this. What is the displacement of a brick that was thrown upward off the side of a building with a velocity of 40 meters per second if it's in the air? So your initial velocity here is 40 meters per second, all right, because they're telling us it's thrown upward. So that speed is going to be a positive value. If they said it was thrown downward, we would make it negative. All right, negative 10 meters per second squared, and the time here was 6.9 seconds. Nice. So let's go to the equation. E, control, comma, y is equal to VI, which is 40, times time, which was 6.9. So I don't need to write seconds because plus, now you're going to do 1/2 b, which is negative 10, times b squared, which is the 6.9 control period squared. Okay, and this, guys, is very important. You're only squaring the time. You're only squaring the time. So I go underneath this. Okay, I'm going to do the 40 times 6.9 free calculator. 40 times 6.9, 276. So I'm going to go write that underneath. That's 276. Underneath here, I'm going to bring down the plus sign. Why do I do it like this? Just because everything is nice and ordered and in line. That way you don't forget to add or subtract things. So we have to do 6.9 squared times negative 10 and then divide it by 2. So we go to here, 6.9. We have to go to this button, squared, nope, excuse you, 6.9 squared, good, equals, okay, times negative 10, and then divide that by 2. We're going to get a negative 238.05. Negative 238.05. Okay, so then what's left for you to do is you add these two things together. If this is a 0, you don't need to worry about it. The answer is just going to be a negative value. Okay, but here We're going to add them together. So since this is already there, I'm just going to add our 276 to it. And we're going to get an answer of 37.95. 37.95 meters. So there's the displacement. So this is telling us that it is still above our head. So you threw something up, okay? It's still going to be above us 6.9 seconds later, and it will be at this height. Next problem. Okay, an apple falls out of a tree. It takes 1.75 seconds to strike the ground. What? Forgot the damn question. Finish the question, but I wrote, guys, already out for you what you're looking for. You're looking for dy. So let's put in our given variables. They give us a value for initial velocity. Hells no. So it's 0 meters per second. They don't give it to you. It's 0. Is -10 meters per second squared. And our time here is this 1.75 seconds. So you have your equation. E sub y equals 0 times 1.75 plus -10 times 1.75 total period squared. Okay, so this, guys, is going to be 0. Anything times 0 is 0. Oh, snap, I forgot to highlight all this in red for your answers. Okay. We're going to add. Now we got to do this. Oh, I forgot something. What did I forget? The 1/2 here. Okay. So 1.75 squared. Let's go to the free calculator. 1.75 squared equals this times -10 equals this. Divide that by 2. Shaboom. Okay, so we got a -15.3125. You don't have to write the whole number. You can round it to 2 to 3 decimals. All right. I'm going to use just the -15.31 here. I'm not going to round up. So my answer for that was -15.31. 0 plus that is going to give me a -15.31 meters. Okay, so it's telling me that the apple was up in the tree, so it fell 15.31 meters. That's what the negatives say. It's telling us that it's below its original position. But if they ask how high up was the apple, okay, after you get the negative, all right, the height is just equal to the absolute value here. So same idea for number 3. You guys should be able to do this now. Part 3, time to fall. So a trapeze artist misses the trapeze and falls into the net that is 9.2 meters below. How long would it take him to fall? So this is your equation that I'm giving you guys. You could sometimes see this as 2 times your height or your vertical displacement divided by gravity, but we're just using 10 here, and we're not worrying about, even though this is below, we're not going to do the negative stuff. It's just a little too complicated. So it's 2 times dy over 10. Okay, you're going to do that first, and then you're going to square root it. So in this, given a height or displacement here of 9.2 meters, now what we have to do is we got to do t is equal to the square root of. So I'm going to go into how you put the square root symbol in here. Insert special characters. Now you can either type in square root or kind of make a little squiggle guy over here. And then, hey, there it is, the square root symbol. Click it. Shabam, it appears. Now for the next couple problems, you may just want to Control C, copy that. That way you don't have to redo that each time. But what we're doing is we're doing 2 times 9.2, and then you're going to divide that by 10. All of that is underneath the square root symbol. All right. So what I'm going to tell you guys to do is do what's underneath the square root first. So we're going to do 2 times 9.2 divided by 10. 2 times 9.2 equals, divide by 10 equals, wait, that doesn't seem right. Hold on. 2 times 9.2 equals, yeah, divide by 10. There you go. Now I have to take the square root of this. So I'm going to this spot right here. That is the square root symbol. Now I can retype in 1.84 if I forgot it. Hey, look, answer tells it what the previous answer to the calculation before was. So I can retype it in as 1.84, or if it's a very long number, I can just literally click answer, and it's going to give me the answer. So 1.356 and a whole bunch of numbers. So I'm going to give this 2 decimals. For me personally, I don't know, but how other people are going to do it, but give me at least 2 decimals if possible. Okay. So in this case, 1.35 is an acceptable answer. 1.356 is an acceptable answer, or you could show like the 1.356. Any one of those is going to be acceptable. So I'm just going to use mine as 1.36. And what is my unit for time? It is seconds. Okay, so when you do this, guys, do not forget to square root it. All right, do not forget to square root it. Unless we're dealing with a super high number, all right, for dy, the times shouldn't be too crazy. They shouldn't be very crazy big. All right. So I'm gonna highlight all this dude in red. Let's go quickly. Okay, the next one. Hey, we got 1,000 meters. So t is going to equal square root. Now I can already copy that. So Control V, that pops back up. So we're doing 2 times 1,000 divided by 10. Let's bang it out. Clear. 2 times 1,000 equals, divide that by 10. Okay. If you got a time of 200 seconds, that's a long time for something to be falling. Okay, remember, the equation is you do what's underneath the square root, then you take the square root. So I got to take the square root. Square root of 200, or the square root of that, is going to be our 14.14 on all that's changed. So we're going to call it 14.14. Unit is seconds for time. Shibby. Okay, then you guys are going to get into the other practice set problems. Now, for the practice set problems, all right, the variables are not written out for you. All right, they're not giving you, hey, this whole section is vertical displacement or vertical velocity or time. You have to figure out the information given, what they're asking you for, and then you can type in, all right, your answers to the problems. So, rock is thrown out of a volcano. When it started, much time to hit the ground. How fast was the rock traveling as it struck the ground? Well, they want to know how fast. So which one of these 3 equations am I going to use? Okay, vertical velocity. Velocity is speed with the direction. So when they ask what is the velocity, what is the speed, how fast was it going, using this equation here, the first guy. How high up? How far did it fall? Vertical displacement. You're looking for this equation. You're going to be using this equation. How much time? How long did it take? How long was it in air? That kind of questioning, you're looking for t. So in this problem, how fast? V sub y. So again, to get the subscript, it's control, comma, vy, control, comma again, to get it back to normal, is equal to our question mark. That's a question mark. Oh, look at the equation now. What are the 3 variables I should have? Okay, vi, what else? P, G equals, there you go, and T. So let's type in our information. Were we given initial velocity? No, so it's 0 meters per second. Oh, well, I don't know anything else. They only give us one number in this whole thing. Well, yes and no. All right. If the object is dropped, the initial velocity is 0. If there's no initial velocity given, it's going to be 0. So that's one of your values. Gravity doesn't need to be given because unless you're told you're not on Earth or the gravity is different, it's going to be r negative 10 meters per second squared. So control period squared bet. And the time here was 9.5 seconds. So using the equation v sub y equals pi, which was 0, plus gravity times time. So negative 10 times this 9.5 equals, now again, you can type it into the calculator. All right, well, some of these problems are going to be easy enough where you don't need to. Negative 10 times 9.5, negative 95. Okay, shibby. And that's it. All right, 0 plus a negative 95. Now, if you were given a value here of, like we had, I think it was in the very, very beginning, all right, 42, you would do that. You would add 42 plus a negative value, whatever, and then the difference is going to be your response here. It was 0, so the answer is just going to be our negative 95. Unit is meters per second. I'll let our answers in red. Bingo. Okay, Wile E. Coyote has fallen again. Takes 4 seconds to go splat. How fast is he going? So essentially, they're still asking the same kind of topic here. We have a different time though, so I'm going to erase that. Do we have an initial velocity? No, it's not given, so that's 0. Gravity's negative 10. We are looking for Vy, so let's get rid of these guys here. What is our time? 4 seconds. And you're gonna go through and you're gonna answer the questions here. How fast was it traveling when it breaks? Again, how fast, speed, anything like that. You're looking for Vy. How fast? Vy again. How high? Okay, that's different. So now we're looking at this equation, height, dy. So d sub y equals question mark. Hell yeah. Vi equals 0 because it's not given. Whoop. V equals negative 10 meters per second squared, and T equals, what do they give us here? 9.5 seconds. Hey, wait, didn't we just do something with 9.5 seconds? Oh, snap, yes, but they were asking what was the speed of the guy there. This wanting to know how high up was the rock when it began to fall. So here's our equation that we're going to wind up using. D sub y equals, okay. Vi was 0, so 0 times time of 4. Nope, 9.5 seconds. Choose. 1/2 pt squared, so negative 10. Remember, you're only squaring t in this problem. Underneath, 0 times anything is 0. Bring down your plus sign. 9.5 squared. Why did it do that? 9.5 squared. Okay, there it is. Equals, all right. So you have that. Now we have to multiply that by a negative 10. And then divide that in half, cut that in half. Equals. So now we're going to be here. Negative 451.25. So 0 plus that is going to give us a negative 451.25 meters as our distance. That means we're below, but that's just for the height. All right, so our height is just the absolute value of that, 451.25 meters. And that's how you guys are going to go through and continue. How high is the table? Again, you're looking for dy. How high is the cloud? Well, it's not asking for speed, velocity, how fast. It's not asking us for how long it's in the air, what time. All right, height, vertical displacement, how far above, how far below. Looking for this guy. How high is the cliff? dy again. How many seconds does it take? You're looking for t. How long do you have? You're looking for t as well, again. Okay, so guys, those are going to be how you go through it and you solve these problems. Okay, I hope this helps, and I'll see you.